The ever-shifting target. How changing environments limit adaptation. The ever-shifting target. How changing environments limit adaptation. For decades, evolutionary biologists operated under a widely accepted theory. Most genetic mutations were neutral, neither harmful nor beneficial, simply drifting through generations without much impact. This idea, known as the neutral theory of molecular evolution, proposed that while harmful mutations are quickly eliminated by natural selection, beneficial ones are too rare to significantly influence evolution's course. Now, groundbreaking research from the University of Michigan challenges this long-standing notion. A new study led by evolutionary biologist Jianji Zhang suggests that beneficial mutations might be far more common than previously thought, with potentially profound implications for our understanding of adaptation and how organisms evolve in a dynamic world. The researchers, meticulously analyzing massive datasets generated through deep mutational scanning, observed a surprisingly high rate of beneficial mutations. More than 1% of the tested variants conferred an advantage to yeast and E. coli under specific conditions. This finding directly contradicts the neutral theory's prediction that such advantageous mutations would be exceptionally rare. However, this discrepancy doesn't mean the theory is entirely wrong. Rather, it highlights a crucial missing piece: the environment itself. The study proposes a compelling new explanation: adaptive tracking with antagonistic pleiotropy. A race against constant change, this model posits that beneficial mutations arise frequently but struggle to become permanently entrenched in a population because environments are rarely static. What proves advantageous in one setting might prove detrimental in another. Imagine a species perfectly adapted to a stable ecosystem. Then, a climate shift disrupts the balance. Mutations once beneficial now hinder survival. Zhang and his team demonstrated this principle through experiments involving yeast evolving in both constant and fluctuating environments. Yeast populations adapting to unchanging conditions accumulated more beneficial mutations than those facing periodic shifts in nutrient sources. The reason? In the constantly changing world, advantageous mutations had little time to spread widely before the environment demanded a new set of traits. We're saying that the outcome was neutral, but the process was not neutral, explains Zhang. Our model suggests that natural populations are not truly adapted to their environments because environments change very quickly, and populations are always chasing the environment. Implications for humanity in a changing world. The study has significant implications beyond simple yeast. It forces us to reconsider the extent to which humans have fully adapted to our ever-shifting world. Our species has undergone dramatic environmental transformations throughout history, from the agricultural revolution to the industrial age, and now the Anthropocene. Some mutations may be beneficial in our old environments, but are mismatched to today, Zhang suggests. He cautions that while we might seem well adapted on the surface, the rapid pace of environmental change could leave us carrying a genetic legacy that no longer fully serves us. This could have implications for disease susceptibility, resilience to extreme weather, and even responses to new technologies. While the study's findings primarily stem from experiments with unicellular organisms, they offer a compelling framework for understanding adaptation in more complex life forms. Future research will focus on replicating these experiments with multicellular organisms like humans to see if similar patterns emerge. The adaptive tracking theory sheds light on the dynamic interplay between evolution and environment, challenging us to rethink how we perceive the concept of adaptation itself. It paints a picture of an ongoing evolutionary race, a perpetual struggle to keep pace with change, leaving many organisms perpetually on the cusp of adaptation, but never quite fully there.